Let's explore some fundamental concepts. These concepts underpin many areas of knowledge and are essential for understanding more complex topics. The goal is to provide a simplified overview, breaking down these core ideas into manageable pieces. We will address each concept in a clear and concise manner, using examples to illustrate their application. Understanding the basics is crucial, because these ideas are the building blocks upon which further learning is based. Consider a simple analogy. Think of building a house. You cannot start putting up the walls and roof without a solid foundation. Similarly, in any field of study, you need to grasp the fundamental concepts before you can tackle more advanced material. Now let's delve into the specific concepts. First concept is the idea of measurement. Measurement involves assigning a numerical value to a physical quantity. This allows us to quantify and compare different objects or phenomena. For example, we can measure the length of a table, the weight of an object, or the temperature of a room. The second concept is that of scale. Scale refers to the relative size or extent of something. It helps us understand the proportions and relationships between different objects or quantities. For example, we can talk about the scale of a map, the scale of a building, or the scale of an experiment. The third concept is that of ratio. A ratio is a comparison of two quantities. It tells us how much of one thing there is compared to another. For example, we can talk about the ratio of ingredients in a recipe, the ratio of men to women in a population, or the ratio of profits to losses in a business. The fourth concept is that of proportion. Proportion refers to the relationship between parts of a whole. It helps us understand how different parts contribute to the overall structure or composition. For example, we can talk about the proportion of elements in a chemical compound, the proportion of colors in a painting, or the proportion of different types of people in a society. The fifth concept is that of change. Change refers to the process of becoming different over time. It is a fundamental aspect of the universe and affects everything from the smallest particles to the largest galaxies. For example, we can talk about the change in temperature, the change in population, or the change in technology. The sixth concept is that of energy. Energy is the ability to do work. It is a fundamental concept in physics and is essential for understanding how things move, grow, and interact. For example, we can talk about the energy of a moving object, the energy stored in a battery, or the energy released by a chemical reaction. The seventh concept is that of force. Force is an interaction that can cause an object to accelerate. It is a fundamental concept in physics and is essential for understanding how things move and interact. For example, we can talk about the force of gravity, the force of friction, or the force of a muscle. The eighth concept is that of motion. Motion is the act or process of moving or being moved. It is a fundamental aspect of the universe and affects everything from the smallest particles to the largest galaxies. For example, we can talk about the motion of a car, the motion of the planets, or the motion of the wind. The ninth concept is that of time. Time is a measure of duration. It is a fundamental concept in physics and is essential for understanding the sequence of events and the rate at which things happen. For example, we can talk about the time it takes to complete a task, the time of day, or the time in history. The 10th concept is that of space. Space is the boundless three-dimensional extent in which objects and events occur and have relative position and direction. It is a fundamental concept in physics and is essential for understanding the location of objects and their relationships to each other. For example, we can talk about the space between two objects, the space inside a room, or the space in the universe. These are just a few of the fundamental concepts that are essential for understanding the world around us. By grasping these core ideas, you can build a solid foundation for further learning and exploration. Let's now turn our attention to applications of these concepts. Measurement is used extensively in science, engineering, and everyday life. For example, scientists use measurements to study the properties of matter and energy. Engineers use measurements to design and build structures and machines. And we use measurements to cook, shop, and plan our day. Scale is used in many different fields to represent objects or systems that are too large or too small to be viewed directly. For example, maps use scale to represent the Earth's surface on a smaller piece of paper. Models use scale to represent buildings or other structures at a reduced size. And microscopes use scale to magnify small objects so that they can be seen more easily. Ratio is used to compare different quantities and to express relationships between them. For example, we use ratios to calculate the fuel efficiency of a car, the concentration of a solution, or the odds of winning a lottery. Proportion is used to describe the relative amounts of different components in a mixture or system. For example, we use proportions to determine the ingredients in a recipe, the composition of an alloy, or the demographics of a population. Change is a fundamental concept in science and engineering. We study change to understand how systems evolve over time and to predict their future behavior. For example, we study climate change to understand how the Earth's temperature is changing and to predict the effects of these changes on the environment. Energy is used in many different forms to power our homes, businesses, and transportation systems. We use fossil fuels, nuclear power, and renewable energy sources to generate electricity and to provide heat and light. Force is used to move objects, to hold them in place, and to change their shape. We use forces to drive cars, to lift heavy objects, and to build bridges and buildings. Motion is a fundamental aspect of the universe. We study motion to understand how objects move and to predict their future positions. For example, we studied the motion of the planets to predict their orbits and to understand the formation of the solar system. Time is used to measure the duration of events and to sequence them in order. We use time to schedule appointments, to track our progress on projects, and to understand the history of the universe. Space is used to describe the location of objects and their relationships to each other. We use space to navigate, to design buildings and cities, and to explore the universe. Understanding these fundamental concepts is essential for success in many different fields. Whether you are a student, a scientist, an engineer, or simply a curious person, you will benefit from having a solid grasp of these basic ideas. Now, let's consider a few real-world examples to further illustrate the application of these concepts. Imagine you are building a bookshelf. Firstly, you need to measure the space where you want to put the bookshelf to ensure that it will fit. This involves using the concept of measurement to determine the length, width, and height of the space. Secondly, you need to consider the scale of the bookshelf. If you are building a small bookshelf for a few books, you will need different materials and dimensions than if you are building a large bookshelf for a library. This involves using the concept of scale to determine the appropriate size and proportions of the bookshelf. Thirdly, you need to consider the ratio of shelves to the overall height of the bookshelf. This will affect the aesthetic appeal and functionality of the bookshelf. You want to ensure that the shelves are spaced appropriately to accommodate the books you plan to store on them. This involves using the concept of ratio to determine the optimal spacing between the shelves. Fourthly, you need to consider the proportion of different materials used to build the bookshelf. For example, you might use a combination of wood, metal, and glass. The proportion of each material will affect the overall appearance and durability of the bookshelf. This involves using the concept of proportion to determine the appropriate mix of materials. Fifthly, over time, the bookshelf may undergo changes. The wood may warp, the metal may rust, or the glass may crack. Understanding these changes is important for maintaining the bookshelf and ensuring that it lasts for many years. This involves using the concept of change to monitor the condition of the bookshelf and to take appropriate action to prevent further damage. Sixthly, the bookshelf will need energy to support the weight of the books. The weight of the books exerts a force on the shelves, and the shelves must be strong enough to withstand this force without breaking. This involves using the concept of energy to ensure that the bookshelf is structurally sound. Seventhly, the force of gravity will act on the bookshelf and the books. The bookshelf must be strong enough to resist this force and prevent the books from falling off. This involves using the concept of force to design a bookshelf that is stable and secure. Eighthly, the bookshelf will remain in motion as long as it is in use. the books will be moved around, and the bookshelf itself may be moved from one location to another. Understanding this motion is important for ensuring that the bookshelf is safe and easy to use. This involves using the concept of motion to design a bookshelf that is both functional and user-friendly. Ninthly, the bookshelf will exist in time. It will be built at a certain point in time, and it will be used for a certain period of time. Understanding the time frame for which the bookshelf will be used is important for choosing the appropriate materials and construction methods. This involves using the concept of time to plan the construction and maintenance of the bookshelf. Tenthly, the bookshelf will occupy space. It will take up a certain amount of space in the room, and it will affect the way that the room is used. Understanding the spatial relationships between the bookshelf and other objects in the room is important for creating a functional and aesthetically pleasing environment. This involves using the concept of space to design a bookshelf that fits seamlessly into the surrounding environment. As another example, consider a simple electrical circuit. Firstly, you measure the voltage of the power source using a voltmeter. This measurement gives you the electrical potential difference that drives the current through the circuit. Secondly, the scale of the circuit I.e., whether it is a small circuit powering a light-emitting diode or a large circuit powering an appliance dictates the components you will use. A larger circuit will require components with higher voltage and current ratings. Thirdly, the ratio of resistance to voltage determines the current flow in the circuit according to Ohm's law. Understanding this ratio is crucial for designing a circuit that operates safely and efficiently. Fourthly, the proportion of resistive, capacitive, and inductive components affects the circuit's overall behavior. This proportion influences the circuit's impedance, frequency response, and power factor. Fifthly, as the circuit operates, its components may heat up, and their characteristics may change over time. Understanding these changes is vital for ensuring the circuit's long-term reliability and stability. Sixthly, the electrical energy supplied by the power source is converted into other forms of energy, such as light, heat, or mechanical work. Understanding how energy is transferred and transformed within the circuit is essential for optimizing its performance. Seventhly, the electromotive force, or volts, drives the current through the circuit, overcoming the resistance of the components. This force is what enables the circuit to perform its intended function. Eighthly, the flow of electrons constitutes the electric current, representing the motion of charge carriers through the circuit. Understanding this motion is fundamental to understanding how the circuit operates. Ninthly, the circuit operates over a period of time, and its performance may degrade over time due to component aging or environmental factors. Understanding the time-dependent behavior of the circuit is important for predicting its lifespan and planning maintenance. Tenthly, the circuit occupies a certain amount of space on a circuit board or within an enclosure. Understanding the spatial arrangement of the components is important for minimizing interference and ensuring proper cooling. In summary, understanding the basics provides a foundation for learning.